At the end of the last episode, I made you a promise. We proved that the most powerful machine ever built can create matter, but it cannot create consciousness. So the question became unavoidable. If consciousness cannot be built, where does it come from? To answer that, we cannot stay in a laboratory. We have to travel. 13.8 billion years from the first fall of the first cloud of matter to the bottom of a black hole. This is the oldest map humanity ever tried to draw. So, we painted it. This is part 1 of 2. Let us start with the most familiar force in your life. The one holding you in your chair right now. Newton called gravity a force of attraction. Objects pulling on each other across empty space. It worked. It predicted the tides, the orbits, the falling apple. Then Einstein arrived and said something stranger and more beautiful. There is no pull. Mass curves the fabric of space and time, and things simply fall along those curves. In my book, Connection, I take that one step further into a single sentence. Gravity is not attraction, it is direction. Bodies of lower density move toward bodies of higher density. That is, the entire choreography of the cosmos. The universe, from its first moment, has one preference, one obsession: density. Everything that exists is quietly moving toward the heaviest thing around it. Remember this, because everything you will see in these 2 episodes is this same principle, repeating itself at larger and larger scales until it breaks through the wall of reality itself. Go back 13.8 billion years. The Big Bang. 380,000 years later, the universe releases its first light. And then, darkness. For millions of years there are no stars, no galaxies, nothing shines. The entire cosmos is a cold ocean of primordial gas, hydrogen and helium drifting in the dark. Astronomers call this era the Dark Ages, and even if these dates are refined or rewritten in the future, as new observations suggest the universe may be older than we think, the principle we are about to see remains exactly the same. It looks like nothing is happening, but something is happening. Gravity is working. Some regions of that primordial gas were, by the smallest fraction, denser than others. And density is destiny. The thinner gas began drifting toward the thicker gas, slowly, patiently. Over millions of years, the gas gathered itself into immense cold clouds, and inside those clouds, the gathering continued, spiraling inward toward the densest point. Nothing was pulling. Everything was falling toward the heavier bodies. Now watch what density does when it wins. At the heart of a collapsing cloud, matter piles onto matter. Pressure builds. Temperature climbs. A dim ember forms in the darkness, a protostar wrapped in its spinning disk of gas and dust. And when the core reaches around 10 million degrees, hydrogen atoms are pressed so hard against each other that they fuse. They become helium. And in that fusion, light is born. Somewhere in the first few 100 million years, the first stars ignited, and the Dark Ages ended. Our best simulations suggest those first stars were giants, tens of times, sometimes hundreds of times the mass of our Sun. And the reason is beautiful. Heavy elements are what cool a cloud down and let it break into small pieces. With no heavy elements yet, the primordial clouds could not fragment. They collapsed in enormous clumps, and enormous clumps make enormous stars. Here is the sentence I want you to keep. A star is not a fire in the sky. A star is a fall, held back by fire. Gravity crushing inward, fusion pushing outward, locked in balance for millions or billions of years. Every star you have ever seen is an interrupted collapse. Think about the sequence. Particles became atoms. Atoms were not the end. they became molecules. Molecules were not the end, they became molecular clouds. Molecular clouds were not the end, they became stars. At every step, the same movement toward density gathered simple things into something more complex, more structured, more capable. And you, watching this, are very far up that staircase. But those first stars had a problem. They were made of hydrogen and helium, and almost nothing else. No carbon, no oxygen, no iron, no calcium, which means no planets, no oceans, no blood, no bones, no you. For the universe to make you, the first stars had to do one more thing. They had to die. And a giant star dies like nothing else in nature. When the hydrogen runs low, the core contracts, gets hotter, and starts burning helium into carbon, then carbon into oxygen, then neon, magnesium, silicon. Layer upon layer, like an onion, each shell forging heavier elements until the chain reaches iron, and iron is the ash of the universe. Every element before it releases energy when it fuses. Iron consumes energy instead. So, the moment a star builds an iron heart, the fire goes out, and nothing is left to hold back the fall. The iron core, a sphere heavier than our Sun, collapses in less than 1 second. The outer layers come crashing down at nearly 1/4 of the speed of light, hit the impossibly dense center, and bounce. The rebound becomes a shock wave. The shock wave becomes a supernova, an explosion that can briefly outshine an entire galaxy, forging in its extreme heat the final elements: gold, silver, uranium, and throwing everything the star ever built across the void. The calcium in your bones, the iron in your blood, the oxygen you are breathing between my sentences. You have heard that we are stardust. You are not made of stardust poetically. You are made of it literally, atom by atom. And then, gravity begins a new dance. The explosion dissipates. The glowing filaments drift, cool, and fade. But over millions and millions of years, the less dense keeps falling toward the more dense. The scattered ashes of dead stars gather again into new clouds, richer now, carrying the new elements. And from those enriched clouds, new stars ignite. Among them, new giants, born already carrying carbon, oxygen, and iron, the inheritance of the dead. But when one of these massive stars explodes, something new can be left behind. A core that does not explode. A core so dense that gravity crushes the atoms themselves, pressing electrons into protons, until what remains is a sphere the size of a city, containing more mass than our entire Sun. 1 teaspoon of it would weigh billions of tons. A neutron star, the densest object the universe knows how to make. Next episode, Part 2. We follow the fall past the neutron star into the object where the fall never stops, and to the answer of the question that started all of this: where consciousness comes from. Everything in this episode comes from my books, a work about the force of consciousness, and Connection, the reality behind all realities. Links in bio. Until then, fly rooted.